Good morning, everyone, and welcome to this week's edition of a Boundaries Webinar Wednesdays. Today we're going to be covering what's new in Mathcad Prime 3.1. And I know a couple of you just asked questions. I know the chat window says, Creole layout for 2D and 3D design. But that's wrong on the GoToMeeting, and this is actually going to be only about Mathcad Prime 3.1. And so we apologize for that. Just to make it clear, we're only going to be talking about Mathcad Prime 3.1 in this webinar currently. And this time we'll give it another 3 or 4 minutes here and wait for more attendees to jump on, and then we'll kick it off and get started. All right, we'll go ahead and get started. Looks like we have a critical mass of attendees here. So welcome once again to the webinar. My name is Sheyi Shambora, and I will be guiding you through this webinar. So the way things are going to go today, just to sort of set the stage here, is first off, we're going to go through just a quick introduction, talking about who we are as boundary systems, and then going to a couple of poll questions, just so that we get a feel for our audience and who we're presenting to. And then we're going to go into some of the different things that are new in Mathcad Prime 3.1, and then I'll show a live demo of one of those items there, particularly the Mathcad and Creole integration. And then after that, we'll open the floor up for Q&A. And so on that note, I'll mention a couple of things. When it comes to Q&A, on the right-hand side of your GoToMeeting panel, it should be on the right-hand side of your screen. You may have to click on the red arrow to pull it out. But in that pane, there's one of the entries in there says questions. And so right now, everyone is muted, just so that way in a webinar we don't have 50 people talking over each other trying to ask their questions. And so if you want to ask a question, you can type it in the questions panel in the GoToWebinar pane. And at the time for Q&A, I will revisit those questions and answer any questions you have. And so as the webinar goes on, you can type whatever questions you have, and then I'll answer those questions as time goes on. So just a quick slide about us here. We are Boundary Systems. We are a technology leader in our field of product development consulting, and we primarily do everything from CAD data management and lifecycle management to CAD design and consulting, to also simulation consulting and also sales as well, and so and then also product development as well. And again, just this slide gives you an idea of some of the different companies we've worked in in our field. And we've also garnered some awards along the way as well. And the way we like to think about it is we look for solutions to our customer problems, and we only grow if our customers grow. And again, that's been evident in the awards that we've won. All right, so before I actually start this here, let me flip back one slide. I will toss out a couple of poll questions just so that way we gauge where our audience is at. And so I'm going to start off a poll question here. So have you used Mathcad in the past? All right, and I want everyone to put in an answer here. So if you've used Mathcad Prime, or if you've used the old Mathcad before the Prime series, so Mathcad 15 and older. If you've used any of those, you can put in your responses in there, and also so just fill that in. We'll give it a couple seconds. Just so that way everyone, okay, yeah, there we go. So we have everyone voted, so we'll go ahead and close the poll, and we'll share that here. And right now it looks like basically almost 70% of our audience here is currently using Mathcad, and we combine that with those that have used it in the past. That's basically 8 out of 10 people. Which is a huge number, and then we have a few people that are currently users of Mathcad. So that's okay. Thanks for the feedback on that one. So we'll go ahead and show another poll as well. And basically, we just want to get a feel for what CAD software you currently use. Be it SolidWorks or Autodesk Inventor. Or also, Creole, and or if you use Pro Engineer as well. I know some people, refer to it as Pro Engineer. Which one of those do you use? Or if you're not a CAD user, you can mention that in there as well. And we'll give a couple seconds for people to vote. I think we have almost everyone voted. Okay. So we'll go ahead and close the poll here, and let's share that. Now this one here is actually surprising. It looks like about a third of everyone on here uses some form of Autodesk, probably Autodesk Inventor. And then next in line is Creo, and then some other CAD packages as well. And then only about a fifth of people on here are not CAD users. So we'll go ahead and hide this here. Thank you so much for your input on that, by the way. I'll go ahead and present the rest of the webinar, and at the tail end of things, I'll bring out one more poll question to to sort of wrap things up. Okay, so first on the list of highlights or things that's that's new in Mathcad Prime 3.1 is the Mathcad and Creo integration. And so with Creo 3.0, PTC has basically embedded Mathcad Prime into the user interface of Creo. And so basically what now happens is right on your ribbon inside of Creo, you have a link or a command that will immediately open Mathcad Prime, and you can either create a new Mathcad worksheet, or you can embed an existing worksheet of Mathcad into your Creo model and use it that way as well. And so this then allows you, all of the word processing capability of Mathcad Prime, and also the calculation engine Mathcad Prime as well. And so the benefit then being that you can, quickly validate your designs, or you can also perform, analysis-driven design. You can have formulas that lead to, a certain result where it says, for example, the diameter is 2.5, and then push that parameter into Creo Parametric to control, a dimension in your model to make it 2.5. And so that's, again, the benefit of using Mathcad with Creo. Another huge benefit, which I know that I usually benefit from, and I know a couple of people have mentioned as well, is that for long-time Creo users or Pro Engineer users, you'll know that the relations box inside of Creo is not so user-friendly. It's typically clunky at best. And so this is one of those areas where, instead of typing equations into the relations editor and wondering if I did it well and keeping my fingers crossed, I can just put those into Mathcad. And the benefit with Mathcad is, I can troubleshoot those equations if there are errors, and I can also add, text boxes to, describe or comment, what I'm actually doing in those equations. And so it's a huge benefit to have the Mathcad and Creo integration, and we will show an example of this. Next on the list of what's new is the API. So with the older Mathcad 15 and older, the API was accessible, and you could program different things and link Mathcad to other applications that you had. With Mathcad Prime 3.1, the API has now been released again or opened up, and so you can integrate Mathcad Prime with any of your third-party tools and then use it to automate whatever processes you have. In addition to that, the Mathcad Prime SDK is also available, and basically the Mathcad, so the API, first off I'll say this, the API comes standard with every installation or every seat of Mathcad Prime 3.1. The SDK, the Software Development Kit, is an add-on that basically contains about 9 or 10 different examples of Mathcad Prime using the API functionality to link to other programs or to create certain program-specific tools. Now, part of the reason why the SDK is beneficial is that all of those 9 or 10 examples are written in many different languages. So, it has examples of, APIs, examples written in, C++, C or C# or Java. And so that way, you're not just looking at everything from one frame of reference. If you're familiar with a particular programming language, you can see examples that have, that programming language in there. And that particular SDK is available from PTC, and I think it costs about $9,000 per company. So it's one fee for and the whole company will have access to that. But again, you don't have to get the SDK to start integrating Mathcad Prime with any of your third-party tools. You can just use the API straight out of the installer. Now, a couple other new things that are there as well. So you can now read and write, HDF5 and ODBC compliant. You can read and write files to HDF5 and ODBC compliant databases. And I know HDF5 was one that's also used with MATLAB as well. And so again, they've opened the functionality for that. You can also write out DXF and an SBL file from Mathcad curves, which again makes the integration with Creo even more beneficial, because now you can basically use a mathematical equation to generate a curve, and then push that curve to whatever CAD package you have, and use that, and then start to generate sweeps with those mathematical curves. And then also there's an integration into Mathcad with CoolProps, and CoolProp is a thermophysical equation. What's it called? Function that's, I think it's an open source tool, but basically it has tons of different functions that can give you basically the fluid properties of many different materials or many different fluids at different temperatures, and so whenever you need those material properties, Mathcad has a DLL that basically wraps around that, and it allows some of those CoolProp functions to be available from within Mathcad, and so that way you can use functions from within Mathcad. And this is open source, so you can go to SourceForge, or you can just Google CoolProp fluid properties Mathcad, and you will find links in Google there that they talk about that integration. And then next up on here is a Worksheet Libraries as well, and so I think with every release of Mathcad, PTC keeps on releasing new and better worksheets that show specific use case examples of Mathcad, and not only that, but it also all of these worksheets are also downloadable as well, and so you have everything from examples of using Mathcad in the construction industry to physics, and it contains all the equations and text to explain everything. And so if you want to look at examples of how people are using Mathcad, or if you just want to look at a common file that many people in your industry are running calculations off of, you can use Mathcad you can use the Worksheet Libraries to take a look at that as well. And then finally here, when it comes to large data sets, I know on 64-bit architectures, now this doesn't apply for 32-bit, but on 64-bit machines, in older versions, it was limited to 2 gigs of you were limited to read in files that were less than 2 gigabytes in size. But now they've opened that up, and where it has that 2 GB ceiling to it. It's now open. Okay, so at this point, I'll pause the PowerPoint here, and we will switch gears and go into a live demonstration here, showing a couple of the functionalities that I just talked about. Okay, so the first thing I was going to hit on is the SDK, or not SDK, the API. And now with every install of Mathcad, you have the API included, and so the way to access that is you can it's a COM-based API, and you can access it using Microsoft Visual Studio, and if you don't have a paid version of that, there's a free version, Microsoft Visual Studio Express, which I'm currently using, and almost all the examples in the SDK were created using the free version. So you don't even have to go purchase Microsoft Visual Studio for you to be able to start using the API. But it's a COM-based API, and basically it's a DLL. So if you go here and open the file, you go to your installation directory wherever Mathcad Prime is installed on your machine. In my case, it's CPTC Mathcad Prime 3.1, and I basically scroll down to the P category, and this is the one I'm looking for here. This PTC Mathcad Prime Automation.dll. This is where the API content is. And so when you open that, you end up with this here, where it has all the different things for you to basically start creating your own programs or your own API to link Mathcad Prime with other programs. So and there are two flagship API tools that have been developed out of this, with Mathcad Prime 3.1, and I think it's particularly useful for our audience here. Some of you are Autodesk users. There is a Mathcad Prime to Autodesk Inventor integration that's been developed, and that's available as well through, you can get that through Boundary Systems, and that's free, by the way. It's not paid. So we can send you a link, you download it, and you can integrate Mathcad Prime Express, which is free, to Autodesk Inventor as well. And then likewise, another big example of that is the SolidWorks to Mathcad Prime 3.1 integration as well. So that was developed off the API, and now you can link a Mathcad Prime worksheet to your SolidWorks model, and you can run calculations from Mathcad, push the variables into SolidWorks, and likewise read in information from SolidWorks back into Mathcad as well. So I'll pause here with this and switch gears to talk about the integration with Creo Parametric. Okay, so now when it comes to Creo Parametric, so this is Creo 3.0, and right now, if you go over to your Applications tab, what you'll notice is that you now have a new calculation group where you have access to Mathcad. And now when you click on that button there, you have a couple of options. So you can either open or create a brand new worksheet from scratch, or you can insert a worksheet, which means you're basically taking an existing worksheet and embedding it into Creo Parametric part or assembly file. Now, if we go ahead and dive into this here to show what's actually going on. Okay, so if we go ahead and dive into this here, this is going to work through a particular example of this here. I already have a Mathcad worksheet created, and this is basically to optimize the profile of my piston head. And so in my design over here, if I go back to Creo, That spherical cap right in the middle there is what I'm looking to optimize. And when you talk about optimizing that, really, what you're looking for is a couple of things. In that region there, you want to have the most volume and yet also the least surface area. And so the bigger the volume, the more air you can have in there. And in this particular case, there's more air for for your field to burn. And heat can only escape in that particular case. At least there's some heat that escapes through radiation, but aside from that, primarily that heat will escape from that combustion chamber in the engine is through surfaces. And so once it gets in contact with a metal surface, you have conduction and heat escapes. The more heat that escapes, the less efficient your car engine is. So you want to minimize the surface area that allows heat to escape as well. And so this is actually a fairly common calculation in the automotive industry that engineers try to to maximize in order to get that shape just right in the combustion chamber. Now in this example, we have other requirements as well. We want to be within a certain compression ratio, and we know that the engine that we're designing this V6 cylinder for not V6, it's an i6. It has a certain displacement range that we want to keep it between, and we also have certain low and high values for what the engine spherical cap at the top should be. And then the rest of the worksheet just goes into a bunch of different calculations that Mathcad does, and really the aim of this is right at top dead center to maximize that volume in there and minimize the surface area. And so Mathcad, so within a whole bunch of equations, and finally Mathcad then uses a solve block to say based on those equations and based on our constraints, let's solve to find the optimal dimensions for that spherical cap at the top that I showed you. So we'll move back up to our worksheet, and starting from here, what we'll do is we will go into Creo. And now from here, we'll tell Creo, let us insert a worksheet into an existing Mathcad worksheet. Go ahead and click on this one here. Hit open. And now, one of the ways you'll know that a worksheet is embedded into a Creo model is that you'll have that Creo icon at the top of the worksheet. So in this case, it's an assembly, so it has the assembly Creo icon over here. And so now, if I can now start going down through this and say, these are my two input values. These are values that I want Creo to push towards Mathcad. And so we'll go here and assign those as inputs. Now another difference as well between another way to tell that a worksheet is it's embedded into a Creo part or assembly part, into a Creo model, is over here you have the save and push. And so what that will do then is that will not only save the file, but also push whatever input or output variables you have to an external client. So in this case, Creo. Now when I come into Creo, I can come here and I go to my parameter section. Let's say all sublevels, and now you'll notice I have two parameters, depot and arc crankshaft, and you notice Creo tells me both of those were inputs from PTC Mathcad. And so at this point, I'll go ahead and do a little bit of prep over here, and we'll hide this, and we'll go ahead and create just a quick Creo analysis. And I'll go ahead and say make feature, and we'll call this feature crank radius. Okay, and really what we're doing with this feature is we're basically taking that the center of of that circle there to the center of the other circle, that's basically the radius, or I guess half the distance that the piston travels. So in other words, the distance between those two centers gives you half the distance that this piston head travels vertically. And that is needed in our calculation. So we'll go ahead and save that as a parameter. And shortlist that. Okay. Now we'll go into our Creo relations box, and this is where we can now start tying things together. And so this is where we can now tell Creo a couple things. First off, we'll say, okay, let's take that parameter, and also this other one here. Let's insert both of those for relations. And now we'll go ahead and say the bore diameter is going to be this dimension here, this D12. So that's basically the diameter of each piston. And then our crankshaft radius here is going to be that feature that we just created, that diameter there. So the crank radius right here, we're going to go ahead and insert that dimension into the relations, and then we'll check here to set the relations to be unit sensitive as well. Let's verify that everything is okay. Yeah, and now you'll notice over here, Creo tells you here in your notification center that you have an outdated Mathcad worksheet, because now it understands that they're linked together, and it's basically saying I have some information I want to pass to Mathcad. Now, another way you can tell that the Mathcad worksheet is embedded into your Creo model is from within your Creo interface. Once you have a worksheet embedded, you'll have this small Mathcad glyph at the top right corner, and clicking on that will immediately pop you into the Mathcad worksheet that's embedded into that model. And so now from here, you'll notice I just tied those two together, and now I come into Mathcad and I tell it update inputs. And you watch those two yellow regions. When I click over here to update inputs, now it reads in the values from Creo, and now it's pulling in the actual dimensions of those two variables from Creo. And so it runs through its calculations, and finally, at the end of it all, Mathcad comes out and says, okay, based on those calculations, these are the optimal dimensions for your piston cap. And so we'll go ahead and make these output regions. It's going to be an output, and this is also going to be an output as well. And we'll pop this out here, so our input and output boxes, just so that way we can see, what variables we have designated as inputs and outputs throughout the entire Mathcad worksheets, and also what their alias is, so what other programs will see those variables as. And in this case, we just want to give them names that that we can recognize them by. So we'll call this one RPH, and we'll call this one HDH. Okay, yeah, so both of those are named. And now we'll then, just like before, tell it save and push. Now let's push that back to Creo and let Creo know that we have these two output variables. And now we'll flip back into Creo, and likewise again go back to our parameters, our relations box, and now in this case we're then going to pull in those two parameters. So this is HPH from Mathcad, and also RPH as well. So we'll insert that as well. And now we'll go ahead and in this case what I'm going to do is I'll pull out a specific sketch in here. I believe it is sketch 4. Yeah, one of these sketches here contains that information. So let me see which. Okay, let's try this here. We'll paint this, and we will go again. Okay. I'm going to cut these out, and we actually find the sketch itself. Okay, so it's there. I hit edit. Okay, there we go. So my dimensions pop out. Okay, and then I'll fill out my relations box again. And now I'll just paste those in. And now the RPH, the radius, is going to be this guy right here. And that's going to be equal to the radius from Mathcad. And then the height is going to be this other dimension here. And that's going to be equal to the height from Mathcad. So I just tied both of those together. And let's go ahead and repaint this. Let me verify that's successful. Okay. Now you'll notice Creo here shows, it's yellow. Basically that means, something has changed in the model and I need to regenerate to have the geometry reflect that change. And now I want you to watch this, that spherical dip right here. Notice how it currently is, has that particular diameter, and it currently is the way it is right now. Once I go over here and click regenerate, now that spherical dip opens up, it becomes much wider, and it also becomes much shallower as well. In other words, minimizing that surface area that we have at top dead center. And the other benefit to this as well is because this is this model is patterned basically 6 times. Changing it on one piston basically updates it on every other piston in the Creo model. And now the beauty of this is, now we have a Creo assembly and a Mathcad worksheet that both work together to maximize that particular calculation. Now, if I was in the automotive industry and I'm in the business of making an engine every year to release the next version or the latest and greatest version of the new Dodge Dart, for example, all we need to do now is pull out this same model every year and we update it with our new dimensions, and Mathcad will automatically calculate for us what the optimal dimensions should be for that spherical cap. And in much less time, we can now, start running off with a new design for a new engine. And so again, when you're in the business of, creating standards and practices that can then, have processes that drive them, Mathcad can be a key integrating factor of that because, it seamlessly links with your CAD program. Okay. So at this point, I will pause here and flip back to the GoToMeeting panel for any questions and answers that you'll have. Or actually, before I do the Q&A, I'll do something else here first. I will share the last poll in here. And now the poll basically just says, okay, having seen what you've seen in Mathcad, Prime 3.1, do you see any value in it? Do you think, what, I'm going to go download, a free trial of Mathcad and, play with it myself? Or do you think, what, not for me, that doesn't pertain to, to what I typically do? And we'll just give it a few more seconds here so that everyone votes. Looks like we're still waiting on a couple more people to vote. Okay, so I'll go ahead and close the polls here. And if I share this here, basically it looks like a good majority of you mentioned that you have seen some value in some of the new functionality that's been implemented in Mathcad. So we'll go ahead and close this here and open the floor up for questions. So any questions you have, if you've been typing them into that questions panel there, I'll take a look at them. And if you have any questions now, you can type them into the questions pane of them as well. Okay. Okay. So I just had a question pop up here. So someone's asking, can you insert a Mathcad feature in a specific point in the model tree, like a relationship feature? That's actually a wonderful question. So whenever you're using Mathcad with Creo, let me flip back to my screen. So the answer is almost in a certain sense a yes and a no. So you still have the analysis capability inside of Creo, and right from here you can create a Mathcad Prime analysis. And in this particular case here, it will create an entry that goes into your model tree, and it knows at that instant I will call that Mathcad analysis, and so I will run whatever analysis is Mathcad. This you can still use to push and pull those variables in to Mathcad and from Mathcad. Aside from this here, whenever if you use what's in the Applications tab, that doesn't have a specific point in the model tree where it calls Mathcad. Basically, what that does is it regenerates your features as necessary, or I guess in the order of your model tree. And at any point, a relation tells it to reference Mathcad for a variable. Then it goes to Mathcad to check what Mathcad says, and then pulls in that information. And so technically, you could sort of still insert it at a specific point. The only difference is it tags along with whatever feature Mathcad is coupled with in your model tree. What other questions or comments? Okay, we just had another question. Will this webinar be available online for future viewing? And the answer to that is yes. We are currently recording this session, and once this is over, we will post it up online. So this content will be available afterwards as well. Okay, and we have another question up here. Basically, someone wanted to know, basically comparing Mathcad Prime 3.1 to Mathcad 15, and to be honest, that would be an unfair comparison for me to make because I've been 90 to 95% of my exposure to Mathcad has been on 3.1. And so I can't give a unbiased comparison to Mathcad 15. What I will say though is that we've been keeping track of. We feel like as Prime has been rolled out, many Mathcad 15 and older users have been somewhat disgruntled by some of the Prime features, and and have been asking for some of the Mathcad 15 features to be re-included back into Mathcad Prime. And we feel like PTC is headed in that direction. So, for example, something as simple as the API, that was open in Mathcad 15, that went away in the first couple of Prime versions, but now in Prime 3.1, that is back. I know, for example, something like the spell check that was available in Mathcad 15. PTC has plans to put that back into Mathcad Prime 4.0. A lot of people talk about how, in the older Mathcad versions, you had an ability to save backwards for backwards compatibility. So, from Mathcad 15, you could save as, Mathcad 14 or Mathcad 13 file. PTC is aware of that, and that is a highly requested, functionality that they are looking to implement into Mathcad Prime. And so I will say from that standpoint, there is some of the functionality that's gone away from older Mathcad versions that PTC is, putting back into the software with each release. Now, the other side to that, though, is I will say that when it comes to editing and creating content inside of Mathcad, some of those functions and operations have been dramatically improved in Mathcad Prime. So, for example, being able to edit matrices and create matrices, that's been improved from Mathcad 15 and older. And so, so I can speak to it from that level, but I don't know that I can give, an accurate apples-to-apples comparison. The other thing that I will mention as well is PTC. I know in Mathcad Prime you have the ability to pull out certain toolbars and customize your interface however you want it to be. I know another requested functionality is PTC is looking into being able to customize your Mathcad Prime ribbon. So that way, if you want certain commands in your quick access toolbar, so you can quickly click on them and have them run, they're looking into into adding that ribbon customization into Mathcad Prime. And so again, all of those things are coming back, and it will start to look and feel more like Mathcad Gold as well. Cool. Okay. Looks like the the questions river is drying up here. If you have any other questions, please send them in. The last thing I was going to mention is that and I think I already mentioned this earlier. Already now there are integrations for Autodesk Inventor and also and also SolidWorks as well. And so I know if anyone is interested in that, you can send me an email. My email is up on the screen, or you can contact Sean Moreau. Sean is our salesperson. So if you have any questions about dollars and cents, about maintenance cost and all of that, Sean would be the go-to guy for that. But right now, publicly available, the integrations to Autodesk Inventor and SolidWorks are available. Some of those are on our website. And we also, will send you an email after this, basically with a link to where you can download the free version of Mathcad Prime 3.1 from our website. And so this is stuff that you can, get free and start playing with today. You don't have to sign a contract. You don't have to give us a drop of blood to do that. Yep. And that's everything else going to present. Thank you so much for joining us in this webinar. We look forward to hosting you on next week's webinar when we talk about process integration with Optimus. We will see you next week. Thank you.